Hello, Year 7. Well done everyone for completing the first unit in lockdown. I would say it's quite a difficult one. There's a lot of maths involved there, and if you don't get the maths, then it's really hard for you to understand without help. Now, normally in lessons I'd be able to give you that help, and I feel quite a few people are scared to email me if they're stuck. Please do, if you are stuck on something, just email me. I'm here, and I'll answer my emails whenever I get around to it. Now, that being said, you've all given it a good go, and I'm really proud of you. And we've kept it as much like real lessons as possible. Okay, I don't want to change the learning too much because it's remote, because I want us to do it properly from home. So here's today's first lesson. We're moving on to a new topic. Okay, it's about elements, the whole topic. We've done something similar before when we did the particle model, because we had to learn about atoms, but this is going to be altogether a little bit different. Before I start this lesson, I want to show you this here. This is the best periodic table that you'll get, for the reason that it is the one that you will be given in your actual real exam. Now, this is wonky. I mean, it needs to be rotated. So if you open this in a PDF, okay, you go edit, you go view here, you go rotate view, and you go clockwise. If you can't find that, you press Shift, Control, and plus all together, and there you've got the best periodic table, in my opinion. It's the English one, or the British one, I should say, because the numbers are the correct way around. I believe Europeans use the correct one too. It's just the Americans one is quite popular, where they've got the numbers the wrong way around, which can be quite confusing. Now, just so we know how to read the periodic table, this is your relative atomic mass, and this box here represents the box around the element. So this top number here is your relative atomic mass. So this number is your relative atomic mass. Here is your atomic symbol. Okay, so B, capital B, lowercase e for beryllium, capital L, lowercase I, okay, for lithium. The name is there again, and your proton number or your atomic number is there. So you can see this is the key. This is why I like this periodic table so much. You'll be given, and if you forget what each thing means, the names are right there. That being said, I'm going to minimize this and we'll go straight into the lesson. Okay, let's have a look. So now you've got a periodic table open somewhere. It'd be good if you could print it off. If you can't, that's fine. Just save it somewhere and keep it safe, and that's your copy. We're going to learn about elements and what they are. I'm going to let you read this, so either you can pause this and read it yourself, or you can open it on your own PowerPoint. Now, a little video for you to watch, which I'll let you watch yourself. If it doesn't work, the video, essentially what it's saying is this. So let's say I've got a clamp stand. Sorry, that's a tripod. Let's say I've got a tripod. This is made from iron. If it was pure, and I was able to look at each individual atom, you would see that all atoms in here are iron, and there is nothing else. So you would have, this would be an iron atom, this one is also an iron atom. Yeah, all these are iron atoms and nothing else. And you can see that because they are all the same size and they are all the same color. If it is a diagram, that is usually how they like to show it. And we've done this before. We've done stuff to do with arrangements before, and how we know that this is a solid because it's a nice, neat arrangement. They're all touching. It's all tidy. So, what is an element? Well, we know all substances, I might get a bit tongue-tied there. All substances are made of very tiny particles called atoms. An element is a substance that is made up of just one type of atom. So let's have a look. Copper, carbon, helium, which is inside the balloons. Okay, these all are made from one type of atom, and if you were to look closely at them, you would see copper is made up of just copper atoms, carbon would be made up of just carbon atoms, and helium would also be made of just helium atoms. I'm sure you get the point by now. But if you look, notice If you were to look at an atom in real life, it would not have a colour. You would not be able to see any colour. We draw atoms with colour just so that we can distinguish between them. Okay, it makes it easier for you to understand, or for someone else to understand that looks at your picture. But notice, the copper atoms are copper coloured and a different size to the carbon atoms. So if I had a mixture or a compound that had a copper atom and a carbon atom, I would know that there was more than one different type of atom there. Here we are, helium atoms, and you can see this is the first gas we've seen. All that space in between the atoms shows you that this is a gas, but again, the same type of atom. So this is an element because you've got just one type of atom. Now, okay. If you like to, you can look at the periodic table song. Just Google periodic table song if that link doesn't work. And here is a version of the periodic table. I prefer the one that I've given you, but this one's got a bit more colours on. So, we've done properties of metals and non-metals before. I will just do a few, because you can Google them, and I'm sure we know them. So let's split it down the middle. I don't know why that is not correct. I want to draw. Thank you. There we go. So let's split it down the middle, and we'll say this side is metals and this side is non-metals. We should know our properties of metals because we've done it before. We should know metals are malleable or bendy. Okay, they can be bent into shape. We should know they're shiny if they are clean. And we should know they're sonorous. I'm going to not spell that correctly. Sonorous. I apologise for my spelling. That means they ring. So I know you've seen people that play drums. You've seen a bell. If you hit it, it rings. They are ductile. They can be drawn into a wire. That can be made into a wire. They are hard. They have a high melting point. So these are the ones that you should know. It's hard. Okay, it's got a high melting point and boiling point. Non-metals. Well, they're pretty much the opposite. Non-metals have a really low melting point and boiling point. So generally, non-metals are gases. If you have a pure non-metal, it's generally a gas. Think of oxygen, it's a gas. Nitrogen, a gas. The stuff that comes out of your cooker, if you've got a gas cooker, that's methane. That is a non-metal. It's a compound, but you get the idea, it's a gas. Here, these will be solids. Oh, I don't even know what I'm trying to write there. That should be solid. There we go. Not an I. Oh, just, right, you get the point. Solid. One last time. There we go. Now, generally, if you have a solid version of a non-metal, it will be brittle, which is the opposite of malleable. Okay, that's really all you need to know, because it's going to be brittle, it's going to be dull, it's going to be dull, it won't ring, it won't be sonorous, so they are pretty much exactly the opposite. Now, I'm going to tell you what you need to do now, so I'm just going to skip past this. Get rid of that, discard. Okay. So here you've got a worksheet. I would like you to go through this. And now the answers are on this worksheet. So if you get stuck near the end, you'll find the answers. Use the periodic table to find the symbols for the following. So where's my periodic table? There it is. So you use this to find the symbols. So for example, hydrogen, I'm going to tell you hydrogen because it is in a weird place. Hydrogen is right there. Okay. The symbol will be a capital H. Please copy the symbol exactly as you see it. If it's a capital C and a lowercase c, it has to be like that. I'm going to take the example of, let's take silicon. Capital S, lowercase I. If I wrote that as capital S, capital I, that is something different. If you look, sulfur is a capital S by itself. Iodine is a capital I by itself. So if I write capital S, capital I, I'm saying it's sulfur iodide. It's a compound. Whereas if I write capital S, lowercase I, I've got silicon. So please have a look through these, try and have a go at them. Okay, you'll need your periodic table. The answers are on the sheet below, as I just showed you there. And once you've done that, once you've had a go of that, once you've completed it, please email it back to me. And that should be everything.